At 2 in the morning, while the rest of the house is quiet, the printer is still running. It has been running for 11 hours. The layer lines are building upward at 200 millimeters per second on a Bamboo Lab machine that costs $600 and produces parts that would have required a $20,000 industrial printer 5 years ago. There is something genuinely different happening in the economics of home-based manufacturing right now, and the bedroom 3D printing business sits at the center of it. Whether that business makes money at a scale that justifies the equipment investments, the filament cost, the time, and the very specific operational constraints of running a small manufacturing operation out of a residential space is a calculation that most people starting down this path never complete honestly before they spend the first dollar. The technology shift that made bedroom 3D printing businesses plausible as an economic proposition happened between 2022 and 2024. The Bamboo Lab X1 Carbon, released in late 2022, demonstrated that a consumer-priced printer could achieve print speeds that previously required industrial equipment. At full speed on appropriate materials, the X1C moves at up to 500 millimeters per second with an acceleration profile of 20,000 millimeters per second squared. Older desktop printers from brands that dominated the market before Bamboo arrived, the Prusa MK3, the Creality Ender series, the older Ultimakers, produced finished parts at speeds that made meaningful production volume from a single machine economically marginal. A part that took 4 hours on an Ender 3 takes 40 minutes on a Bamboo P1S. That speed difference does not automatically produce profit, but it does change what is possible from a single machine in a bedroom, and it changed what the math looks like when you run it forward. The current entry-level production machine for anyone treating this as a business rather than a hobby is the Bamboo Lab P1S, which retails at approximately $600. A step up to the X1 Carbon at approximately $1,100 adds a LiDAR-based layer scanning system, more precise motion compensation, and slightly better build quality on certain mechanical components. For someone printing functional mechanical parts or highly detailed miniatures where defect detection matters, the X1C justifies its premium. For someone printing decorative items, organizers, and products where dimensional precision within a quarter millimeter is acceptable, the P1S produces indistinguishable results at almost half the price. Neither machine requires significant ongoing technical maintenance compared to earlier desktop printers. The Bamboo ecosystem is designed around reliability and repeatability, which is economically significant for a bedroom operation, where the owner is often not present to catch problems when they develop. The physical constraints of a bedroom manufacturing space are the first thing that limits scale, and the first thing that most enthusiast content around this subject glosses over. A single FDM printer running at production speed produces between 45 and 65 decibels of noise from its cooling fans, part cooling, and motion system. At 55 decibels, a running printer is roughly equivalent to a normal conversation in volume. In a bedroom at 2 in the morning with a sleeping household on the other side of a wall, that level of persistent noise creates a real practical limit on operating hours that does not exist in a commercial space. Operators who genuinely run their printers around the clock from a bedroom report that household relationships are either sufficiently accommodating or that the printer is eventually moved to a garage, basement, or spare room, at which point the bedroom business designation is technically no longer accurate. The overnight production that is essential to maximizing machine utilization in a single operator 3D printing business is the first economic variable that the residential setting complicates. Particle and VOC emissions from FDM printing are a health consideration that the 3D printing community has discussed at length, but that operators starting a bedroom business frequently minimize in their planning. FDM printing, particularly with materials like ABS, ASA, polycarbonate, and nylon, produces ultra-fine particles and volatile organic compounds, including styrene and caprolactam, depending on the material. PLA, which is the most common and least chemically aggressive FDM material, still produces ultrafine particles at concentrations that are elevated relative to background air quality during printing. Printing ABS or ASA in an unventilated residential bedroom is not a theoretical health risk. Multiple studies have documented particle emission rates from consumer FDM printers that, in an enclosed space without adequate air exchange, produce particle concentrations that exceed indoor air quality guidelines within an hour of printing. The Bamboo P1S and X1C are enclosed printers with built-in HEPA and activated carbon filtration on the exhaust, which mitigates but does not eliminate this concern. An operator running multiple printers or printing materials with higher VOC profiles needs active ventilation to the exterior, not just recirculating filtration, to maintain acceptable air quality in an occupied bedroom. Fire risk in unattended 3D printing is not hypothetical. Insurance claims, fire reports, and documented incidents from hobbyist and small commercial operators have established that thermal runaway events, electrical overload, and in rare cases, failed parts can ignite material inside or around a running printer. Thermal runaway protection is a standard firmware feature on any modern 3D printer, and it works in most cases. In a small fraction of cases, usually involving modified firmware, aftermarket components, or hardware failures, it does not. An operator printing overnight in a bedroom while sleeping faces a category of risk that is present in a commercial space with fire suppression, but that in a residential setting depends entirely on smoke detection and the response time of the sleeping occupant. Standard homeowners insurance policies typically exclude losses resulting from business operations conducted from the home. An operator who starts a 3D printing business from a bedroom without disclosing the business use to their insurer may find that a printer-related fire is partially or entirely uncompensated. Analytically, setting aside the operational constraints, the economics of a bedroom 3D printing business depend on one question above all others, which is what the business is selling and to whom. The product and customer questions determine whether the residential manufacturing model can generate meaningful income or whether it is a hobby that makes its own consumables partially tax-deductible. The answer varies dramatically depending on whether the operator is selling commodity products on marketplace platforms, custom fabrication services to local customers, or specialized products in a defined niche. The tabletop gaming miniatures market is the clearest example of a product category where bedroom 3D printing has created genuine businesses. Dungeons & Dragons, Warhammer, and the broader tabletop role-playing game market generate substantial demand for detailed resin and FDM printed miniatures, terrain pieces, and accessories. The market for officially licensed gaming miniatures is large, but dominated by established manufacturers. The aftermarket for compatible, non-licensed miniatures and accessories is served heavily by independent designers who sell STL files through platforms like My MIDI Factory, Cults 3D, and their own Patreon channels, and by printers who buy those files commercially and produce physical prints for sale. Analytically, the economics of this model work when the operator has a reliable source of commercially licensed STL files, a production process capable of consistent quality, and a customer acquisition channel that connects them to tabletop gaming communities at a price point that reflects the cost of production plus a real margin. The intellectual property dimension of selling 3D printed products is a legal and practical constraint that many bedroom operators discover through experience rather than research. Designs created by other designers and shared on platforms like Thingiverse or Printables almost universally carry licenses that restrict commercial use. Printing and selling a Pokemon character model downloaded from Thingiverse is copyright infringement, regardless of whether the operator is operating from a bedroom or a factory. The large intellectual property holders, Nintendo, Disney, Marvel, Hasbro, and similar companies, actively monitor and issue takedowns, and in some cases pursue legal action against commercial infringers at the small scale. The legal pathway for selling 3D printed products commercially requires either designing original work, purchasing commercial licenses for designs that offer them, or working in categories where no intellectual property constraints apply. Operators who bypass this constraint by arguing that their operation is too small to attract attention are accepting a legal risk that is real even if the probability of enforcement against any specific small operator is low. Resin printing, the other major technology available to bedroom businesses, offers substantially higher detail resolution than FDM and commands higher prices in product categories where that detail matters. MSLA resin printers like the Elegoo Saturn series and the Anycubic Photon Mono series use a masked light source to cure liquid photopolymer resin layer by layer, producing surface detail that FDM cannot approach. The Elegoo Saturn 4 Ultra, one of the leading machines in the prosumer segment, retails at approximately $500 and produces parts with a layer height resolution as fine as 25 microns. The chemical hazards of resin printing in a residential setting are substantially higher than those of FDM printing. Liquid photopolymer resin is a skin sensitizer and potential respiratory irritant. Uncured resin is classified as hazardous waste and cannot be disposed of in standard municipal waste streams. The washing station required for post-processing resin prints uses isopropyl alcohol or dedicated washing solvents that produce VOC emissions during the wash cycle. Seriously, a bedroom resin operation without dedicated ventilation, chemical storage, and a defined hazardous waste disposal protocol is creating a health and compliance problem that will eventually require resolution, either through proper infrastructure or through the end of the operation. The per-machine revenue capacity of a bedroom 3D printing business is the number that sets a ceiling on what this model can achieve, and that is often calculated optimistically in promotional content about the business model. A single Bamboo P1S running for 16 productive hours per day, which is a realistic number for an operator who starts the machine in the morning and checks it through the day, completing most jobs before bedtime, produces a variable output depending entirely on what it is printing. A miniature that sells for $18 and takes 2 hours to print produces $9 of output per machine hour gross. A batch of 20 small organizers that take 4 hours collectively and sell for $40 total produces $10 of output per machine hour gross. Filament cost for a typical PLA job runs at roughly 20 to 30 cents per gram at current pricing for mid-grade filament, and a typical item in the $5 to $15 retail price range uses somewhere between 30 and 120 grams. At 30 cents per gram and 80 grams of material, the filament cost is $24, and if the product retails for $18, the job produces negative gross margin before any other cost enters the picture. That specific arithmetic where material cost exceeds or closely approaches retail price is what drives the price floor calculation that most new operators set too low. The retail price of a 3D printed item needs to cover the filament and supports, the amortized cost of the machine per hour of runtime, the cost of failed prints at a realistic failure rate, the platform fees of selling through Etsy or a similar service, the packaging and shipping materials, and the operator's time for file preparation, post-processing, and order fulfillment. An operator pricing their work by looking at what competitors charge on Etsy and setting a similar price has not done a cost analysis. They have done a market analysis, which tells them what the market will pay, but not whether what the market will pay covers their actual costs. When those two numbers are close, the business works. When they are not, the business generates activity without generating profit, and the operator is effectively paying for the experience of running a printer at a loss. The platform economics of selling 3D printed goods online follow the same structure as any other Etsy or marketplace business. Etsy charges a listing fee of 20 cents per active listing, a transaction fee of 6.5% on each sale, and a payment processing fee of approximately 3%. Add the cost of generating traffic, whether through Etsy's own paid advertising system or through organic social media, and the platform overhead on each sale runs between 10 and 15% of the retail price before any product cost enters the calculation. Sellers who find the Etsy 3D printing category difficult to price profitably are often discovering that the platform overhead combined with material cost and their own labor leaves a margin too thin to sustain the operation at the volume the platform delivers. The operators who make bedroom 3D printing businesses work financially tend to have resolved the product and customer questions before they bought the second printer. They found a specific product category where their quality, their design access, or their production capability gives them a defensible position relative to competitors, and they sell into that category rather than into the general custom product market where every other bedroom printer is competing. Miniature painters who run a print and paint service at premium price points, serving collectors who want finished display pieces rather than raw prints, operate in a segment where value is added through skill rather than through manufacturing speed, and price accordingly. Operators who sell direct to local customers, architects needing site models, small product companies needing functional prototypes before committing to injection molding, schools and educational institutions needing custom parts, are not competing against Etsy's global inventory at all. The local B2B model requires more sales effort than listing on a marketplace, but delivers margins that the marketplace cannot match because the customer is not comparing the price to 30 other Etsy listings. The bedroom to commercial space transition is the point where a successful 3D printing operation either grows into a different kind of business or reaches the ceiling of what the residential model can support. 4 printers running simultaneously in a bedroom generates enough noise, heat, particle emissions, and electrical load that the space is functionally a small manufacturing facility, with all the safety and operational considerations that implies. The electrical load of 4 Bamboo P1S printers at full power draw is approximately 1,200 watts, which is within the capacity of a standard 15-amp residential circuit with reasonable headroom. 6 or 8 printers begin to push against the capacity of a single circuit and require either a dedicated circuit or power management to avoid tripping breakers during simultaneous peak draw at heat-up. An operator who adds machines without assessing the electrical infrastructure is creating a fire risk through wiring overload that standard thermal runaway protection will not prevent. The business that grows beyond 4 machines in a residential setting almost always moves to a garage or basement first, then to a commercial space. The economics of that transition are significant. A commercial space that adds $1,000 per month in rent also adds overhead that the bedroom operation did not have, which means the machine fleet needs to generate proportionally more revenue to sustain the same net income for the operator. Operators who make the transition without having first established reliable recurring revenue at the bedroom scale frequently find that the added overhead of the commercial space, combined with the cost of additional machines to justify the space, creates a financial commitment that the existing customer base cannot support. The bedroom 3D printing business that was marginally profitable at low overhead becomes unprofitable at commercial overhead before the additional capacity generates the additional revenue needed to cover the gap. What a bedroom 3D printing business can realistically provide for an operator who has chosen their product category deliberately and priced their work honestly is a supplemental income of $1,000 to $3,000 per month from 2 to 4 machines running at sustained utilization. That range assumes direct-to-customer sales at margins sufficient to cover material, platform fees, and realistic labor valuation, and it assumes a product category where the operator has differentiated sufficiently that price competition from other bedroom printers is not the primary pressure on revenue. It is not a path to replacing a full-time income from a single machine and a listing on Etsy. The operators who report replacing full-time income from home 3D printing typically have multiple machines, a direct customer relationship rather than full marketplace dependence, and a product or service that commands a price point above what the saturated categories will support. The bedroom 3D printing business is real as a business model. The technology makes it possible in a way that it was not 4 years ago. The economics make it viable under conditions that require specificity about product, customer, and pricing that most entry-level content about this subject never addresses. The gap between what a bamboo printer can produce and what that production generates in net income for its owner is not a technology gap. It is a business model gap, and it is closed by resolving the same questions that any small business has to resolve, which is who the customer is, what they will pay, what it costs to serve them, and whether the difference between those numbers supports the life the operator is trying to build.